I thought I'd go ahead and do number 1985 VC22 from the very beginning, just in case you're still having doubts as to where things go and why. So just talking it through, reading it here, the area of a circular region, and it's always nice to have a picture. Circular region, the area is increasing at a rate of 96 pi square meters per second. So the area, we know that the area, so dAdt, the area is changing at a rate of, it says it's increasing, and so we write that value, 96 pi, and that would be square meters per second. Come on now, square meters per second. And we write that in terms of a positive number because the area is getting bigger, so its rate of change is positive. When the area of the region is 64 square meters, so at that precise moment in time, how fast in meters per second is the radius of the region increasing? Alright, well, if the area is increasing, the radius must be increasing as well. It says it's increasing. So we want the dRdt, the rate of change of the radius, again, at the precise moment when the area is 64 pi. So we just stick that down here. Area is 64 pi. It seems to me like a pretty straightforward problem, but we'll see. Sometimes the ones that look the most straightforward are the ones that cause me the most trouble. But nevertheless, we've got a circle, it says circular region, and we know that we need to relate the variables A, area, and R for radius. So that one formula that screams at you here is that area is equal to pi r squared. That is definitely an equation that relates the area to the radius. Okay, so look what you want. You want dRdt. If you want dRdt, you better get a dRdt in your equation. Now it's not there yet, and we know we have dAdt, but that's not there yet either. So that kind of begs us to differentiate both sides. We're going to ddt both sides. ddt is a verb, a ddt something. Okay. And then on the left side we get our dAdt, because dAdt is dAdt, right? Okay. Well, in the last problem we did the derivative of pi r squared, or some form of that, and we know that the derivative of pi r squared is 2 pi r multiplied by dRdt. Remember when I said that related rate problems have safety nets? Well, again, that's one of them, where you want the dRdt and you know the dAdt. Well, you better get a dAdt and a dRdt in this new equation once you differentiate. So to reiterate as well, in related rates problems, we always are going to write what we want, what we know, and relate. So want, know, relate, and then differentiate. So we're always going to do that. And again, we're always going to differentiate with respect to time. It's always with respect to time, time being the independent variable. Okay, because these quantities are changing with respect to time. Well, this looks pretty straightforward here because we need to solve for dRdt, and we know that we know the dAdt. So I'm going to go ahead and substitute in my dAdt of 96 pi square meters per second, and then so we've got something here that we don't really know, and we do also want our dRdt. So that guy right there, and sometimes I'm glad we finally got one of these in which we have to work for something, because everything else has been kind of hand delivered to us, served up on a silver platter. But this is the R. Okay, that's the R. At the precise moment, though, when what? When the area is 64 pi. Okay, so we haven't used that yet. So if you notice that they gave us that, they gave us that we want the dRdt at the precise moment when the A is 64 pi. Well, so we haven't used that yet. So well, this would be the time we're going to use that. Okay, we again know that area is pi r squared. So if the area is pi r squared, and we also have the area being 64 pi, this is the precise moment. So it's okay now to substitute in the value at that precise moment. So we're needing to solve for r in this case because we've got a quantity for A, A being 64 pi. So we're just going to replace this A with at the precise moment what it is so that we can know at the precise moment what the R is. Okay? So we're going to write 64 pi equals pi r squared, and we can see that we can divide both sides by the pi, and we get r squared is equal to 64. Okay? Well, you might be thinking, well, r is plus or minus 8. Well, yeah, in general, when you solve that equation, r squared is 64, you get r equals plus or minus 8. But we're talking about the radius of a circle. Okay, and the radius of a circle has to be a positive number, so at the precise moment, this is the key to this problem, that the area is 64 pi, the r is 8. So we're going to put the r equaling 8 right there. Okay? Now we can see that we can go ahead and divide, because all we want is our dr dt at this moment. So all we have is constants for the rest of it. We're going to take our 8 times 2 times pi, and we're going to call it 16 pi, so we can divide by that. Divide both sides by that. And we know that 8 times 2 times pi and the 16 pi, those cancel each other out. So we get our dr dt equals, and the pi's cancel here, and 96 divided by 16, be careful here, 96 divided by 16 is 6, so we get dr dt is 6, and we don't even need units of measure here. They don't even put that in any of the solutions, and that 6 right there is choice A. So A is the right answer. So that's a good job if you got that. If you get all of these, you are looking good, because these are not easy problems, but they do follow a pattern. So if you're getting the pattern, that's good. I applaud you for your effort. And if you're not getting it yet, try to just maybe watch a video and just listen to what I'm telling you, and then try to do the problem on your own, and you'll be able to think through it, and that'll be a very helpful learning experience if you're not getting these right the first time.